Okay, so we now have our light source, we have our HDRI, but how are we going to use it? Well, in this video I'd like to look at a very general top-level overview of how we're going to approach using the HDRI, using our light dome to light our CG elements. Now, as this is an advanced shaders DVD, hopefully everyone's already familiar with the idea of what shaders are, along with basic light models for diffuse and specular lighting and the likes. But just to recap, we know that a shader defines how light interacts with a surface. Thus, with our light source now in place, this HDRI panorama that is our light source, we're going to write a shader to determine how our HDRI interacts with the CG surfaces in our scene to determine their final rendered color. We also know that a very basic concept when dealing with shaders and lighting models is the idea of diffuse and specular components. We know that we have this idea of a diffuse component representing light that's hitting a surface that's very rough at the microscopic level, for example chalk, and so the light that hits it gets scattered in all directions, and so we get this idea of diffuse lighting. So we'd have a surface that's very rough, and when light comes down and hits it, it's getting scattered in all different directions, giving us a diffuse surface. And we also have a specular component, which represents light interacting with a smooth surface. Thus, we get perfect reflections, if you will, of our light source off of the surface. So we don't get the scattering that occurs with a diffuse surface. And the specular highlights that we're familiar with shaders such as the Phong lighting model, they're just an approximation of this idea of the reflection of a light source off of our surface. So obviously not all shaders are perfectly diffuse, or rather not all surfaces are perfectly diffuse or perfectly specular. We do have a balance between them, and again another basic rule of lighting models, of shaders, is that we have this general rule of thumb where we say that diffuse plus specular equal a total of 1. And what I mean by this is that the proportion of diffuse lighting coming from a surface and a proportion of specular lighting should always total to a value of 1. So for example, if we had diffuse with a value of 1 and specular with a value of 0, well, that gives us a total of 1, and that's a 100% diffuse surface. Or we could have diffuse with a value of 0, specular with 1, again giving us a total of 1, but in this case it's 100% specular. Let's say we had 0.5 and 0.5, these would total to 1, but now we've got a 50% diffuse, 50% specular, and we could go on, we could say, well, what if it was 0.25 and 0.75, again totaling 1, or if it was 0.75 and 0.25, again totaling 1. We just know that the proportions of these two should balance so that the total amount of light coming back is 100%. It's not going to have more light coming back than originally hit the surface. So our shader 2 is going to break down into the idea of a diffuse component and a specular component. And again, it's going to deal with the idea that diffuse and specular should total to a value of 1. But we mentioned a second ago that the specular highlights that we're familiar with, the idea of the specular component of lighting models such as the Phong lighting model, they're really just an approximation of the reflection of the light source in the surface. Well, we don't need to approximate this. Our light source, our HDRI, has a lot of detailed information about the lighting. If we take a look at our HDRI, there's a huge amount of information here compared to a CG light that just has maybe position, maybe some direction information, or an angle for a cone angle for a spotlight. But we have way more information than this because we have our HDRI. So we're not going to be approximating the reflections of our light source. We're simply going to be thinking of true reflections of our light source, true reflections of our HDRI, as opposed to specular highlights. So I'm just going to bring up a new layer. because we're going to be, instead of thinking of diffuse and specular, we're going to be thinking of diffuse and reflections. And again, with the idea that diffuse plus reflections equals a total of 1. And by using the HDRI for reflections of that light source, as opposed to faking reflections with specular highlights, we're going to get a far more realistic result. And we can think of this in terms of just looking around us right now. I've got a computer monitor sat in front of me that's made out of a sort of glossy plastic material. And if I'm looking at this, I can see that there are specular highlights as we'd think of them with CG lights on this particular object. But those specular highlights are really just a reflection of the brightest lighting information that's hitting that object. But if I look closely around the specular highlights, I can see that actually what I'm getting is a reflection of the entire environment on this object. It's just that where the lighting information is of the greatest intensity, that's where I'm getting those bright specular highlights. By looking really closely, I can actually see reflections of my keyboard on the desk. I can see reflections of myself in the monitor framework as well. So we're dealing with a reflection of the environment, not just a reflection of the light sources. So by using our HDRI, which is our environment, which the entire environment is our light source, if we take true reflections of that, that will give us much more realistic results. So we can think of our diffuse and our reflections as the two components of our shader. So diffuse and reflections. But how are we going to combine them? And also, how are we going to generate them? Well, in terms of generating, each of these are going to be consistent of a series of render passes and also a series of nodes in our shader, and we're actually going to discuss each in turn when we get to that area of the DVD. But we then need to deal with how we're going to balance them, again recalling that we want them to total to a value of 1, diffuse plus reflections total to a value of 1. So we're going to allow the user to specify a 0 through 1 reflection amount. So 0 through 1 reflection amount, whereby this is the reflection component's proportion, and then the diffuse is going to be 1 minus the reflection amount. So diffuse is equal to 1 minus, I'm just going to abbreviate that to RA. So we can see there they're always going to total to a value of 1. We're specifying how much proportion the reflections have, and the diffuse gets whatever's left over from that. So we're going to allow the user to specify this, but we're also going to allow for our reflections to be attenuated based on the viewing angle by using Fresnel calculations. And again, we'll discuss this in greater detail as we get to that section of the DVD. Finally, we're also going to add displacement into our shader, and that's going to allow us to increase the detail on our surface over what's just there by the geometry alone. And this is very useful to us because if we want a realistic rendering, then the more detail that we have, the more realistic the end result's going to be, simply because of the fact that things in our real world are highly detailed. They're not smooth and clean. They have bumps. They have dirt on them. Everything has all these details, and the more of these details we can observe and put into the CG work that we're doing, the more realistic, in quotes, the end result's going to be. So we're going to implement displacement as part of our shader. Now that's not going to give us any extra passes, as we'd hopefully know, but instead it's going to be modifying all of the other passes that are coming out of our shader, because it's modifying the geometry at render time that's being used by all of those other passes from our shader. So really this DVD breaks down into 4 key areas. We have the diffuse component is the first area we're going to look at. We have our reflections component. We then need to look at how we're going to balance diffuse and reflections. So diffuse and reflections balancing, which again is going to look at using that reflection amount along with using Fresnel calculations. And then finally, the fourth area of this DVD is going to look at displacement. So we have those 4 areas that we're going to need to tackle to create our final shader that's going to make use of our HDRI for realistic lighting and shading of our CG elements. So this is just an overview of where we're going to be going in this DVD, and then over the next series of videos we'll take a look at each of these areas in turn, discuss each one in detail, overview how we're going to approach each one in detail, and then implement those areas. But with that, that is going to conclude this video. Thanks a lot, everyone.